This is Algebra 2 with trig. This is Chapter 13, working on our unit circle. This is a unit circle overview. We're going to first talk about a few of the details. The unit circle. The equation of the unit circle is x squared plus y squared equals 1. That's the equation of a circle with the center at the origin. So we know our center is going to be at 0, 0. The equation equals r squared. So if r squared equals 1, then we know the radius would be 1. So unit circle, the word unit referring to a distance or a single value. So it's a unit circle has a radius of 1. All the x values of each point of our unit circle will be the values of cosine. And we'll talk about why that's happening. The y coordinates of each point is sine. When we calculate tangent of a angle, when we're talking about the unit circle or really any right triangle that we're calculating, would be doing the opposite over the adjacent. And on the unit circle, the opposite are always the y values and the adjacent is always the x values. So you could call that sine over cosine. That's a trig identity that you will most definitely be using even in pre-calculus. When we speak of learning the unit circle, we'll be learning the measures of special angles, all the degrees. In geometry, you learned about the 30, 60, 90 triangle, also the 45, 45, 90 triangle. We'll be doing multiples of those all the way around the circle. You'll also do the radians for all of those same measurements, the coordinates for where the angle touches the circle 1 unit out. With a radius of 1, what is that coordinate? Those are going to be cosine, sine, x, comma, y values. Those are coordinates, just like any xy axis coordinate. We also will evaluate where the sine, the cosine, and the tangent are for all of those special angles. Okay, we also have quadrantal angles. They're in standard position with the side on an axis. Okay, it's always a multiple of 90, and the radian equivalent of 90 is pi over 2. Think about what the full circle we call 360. So the radian, we call that 2 pi. Half a circle would be half of 2 pi, so that would be pi. 90 degrees is half of 180, so it's half of pi, so pi over 2. And you could label that as being a radian. Now we'll talk about those special right triangles. We have the 30, 60, 90 triangle we'll talk about first. We'll have a right angle. We'll have our point down here at the origin. The unit circle would come through and touch way out here at a coordinate of 1, 0. So a 30-degree angle wouldn't, the triangle would not touch way out here at 1. It's the radius, the hypotenuse would be 1. So now, if we have this 30, 60, 90 triangle, we can find the length of the short side and the length of the long side. The hypotenuse equals the short side times 2. So if the hypotenuse is 1, we know that the short side is being multiplied by 2 to equal the 1. So we divide by 2, and we see that the short side would then have to be a half. If the radius is 1, which it is for the unit circle, then the short leg is always a half. The long leg equals the short leg times root 3. So we don't know what the long leg is, but we know the short leg is a half times root 3. So to simplify that, we would say root 3 over 2. So now we know the long leg is root 3 divided by 2. Notice that root 3 is always a bigger value than a half. They both have the same denominator. Square root of 3 is bigger than the square root of 1. Square root of 1 is 1. Square root of 3 is larger than 1. So in a 45, 45, 90 triangle, where the radius comes up and touches the edge of the circle, here we would have 0, 0, 1, 0. The radius of the circle is 1. So to figure out the sides of our 45, 45, 90 triangle, we have our formula that the hypotenuse equals the leg times root 2. So if the hypotenuse is 1, the leg, we call it leg, not short leg, just because both legs are the same length in a 45, 45, 90 triangle, times root 2. We would need to divide by square root of 2 to get the leg by itself. So that's 1 divided by the square root of 2. We're not allowed to leave the square root of 2 in the denominator, so we have to rationalize the denominator. So we're going to multiply by a value of 1 that'll help the radical not have a square root in it. So when we multiply straight across, we get square root of 2 over square root of 4. So each leg is root 2 over 2 and root 2 over 2. They're the same thing because 45, 45, 90 triangle is an isosceles triangle. Next, we're going to talk about making the unit circle. All of these different spots need to be filled in when you complete your unit circle. You're going to have degrees, radians, and coordinates all on our unit circle. Let's start with degrees. Probably the easiest one to work with. We do all our measuring from the positive x-axis, so we're here at 0 degrees. At 0 degrees, to turn 90 degrees, a right angle, we would be up here at 90 degrees. 90 again gives us 180 degrees. 90 again gives us 270, and then 360 degrees. Now we see we have angle values in between all of these. Well, the unit circle, we only look at special angles. We only look at multiples of 30 and multiples of 45. Those are all our special angles. So multiples of 30. 30 would be our first angle that we'd come to. So that's 30. Look how big that step is, that angle is. So 30 and 30 is going to go up to the next line. This would be your 60. 30 more goes up to your 90. 30 more comes over to your 120. Again, 30 more is 150. Plus 30 is 180. Plus 30 is 210. Now notice that it's the big angle. We don't stop at the halfway point. 30 more would come over to 240, 270. A big angle, 300. This is a small angle. This is a small angle, but it's big to get over to it. So that's 330. And then, of course, 360. The last ones that we haven't talked about, remember we do multiples of 30 and we do multiples of 45. 45 should go right through the center of each quadrant. So 45 goes down the center. 45 more degrees is your 90. 45 more degrees is 135. And 45. 45 more degrees, 225. 45 more. 45 more, 315, with 45 more to 360. So in practicing the unit circle, you want to become pretty confident that you can figure out what all of those angle values are. Some people like to teach it that you would go by 15s. You don't do a few of those multiples of 15. You don't do the 15, but you do 30 and 15 more and 15 more, up to 90. Jump over to 120 and 15 more, 15 more. They're all 15 apart from each other, but you don't do the multiple that's next to your axes. That's one way to think about it. I just think of multiples of 30, multiples of 45. Now we'll talk about radian. Radian is when we talk about the pi. So we'll start at the very beginning angle, and that would be 0 radian. We know that the entire circle of the unit circle, or of any circle for that matter, is considered 2 pi. We've discussed that it takes about 6.28 radians to go around the entire circle. So 6.28 is 3.14 times 2. So that's 2 pi. So half of a full circle is a half circle. So half of 2 pi is 1 pi. We can just write it as pi. When we cut that in half, we would be pi divided by 2. Don't use half pi, it's the same thing, but pi over 2 is the way we typically write that. If 90 degrees was half a pi, another 90 degrees was 2 halves of a pi, another 90 degrees is 3 halves of a pi. So 3 pi over 2. And then another 90 degrees would be 4 halves. 4 halves is 2, so 2 pi. Now we want to look at some of these special angles. What would 30 be in terms of a radian? Well, 30 goes into 180 6 times. So we're taking the pi and we're dividing it by 6. So that's going to be pi over 6. we can look at 60. 60 goes into 180 3 times. So it breaks it into 60, 120, 60 more, and 120, well, 60 and 60 plus 60 more takes you to 180. So there's 3 of those big steps of 60. So the radian is pi over 3. If it's 1 pi over 3 to get to 60, then it's 2 pi over 3 to get to another distance of 60. 3 pi over 3 to get to another step of 60. 4 pi over 3. 5 pi over 3 to go 60 more, and 6 pi over 3. So think about each of our steps that we would go by 60-degree increments. Pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3. 60 plus 60 plus 60 plus 60 plus 60 plus 60. Now we can do the 30s. Well, we said the 30 was pi over 6. 2 30s would be 2 pi over 6, and that gets reduced. Another 30 would be 3 pi over 6. 3 over 6 is 1/2, so it's pi over 2. Another 30, 4 pi over 6. Another 30, 5 pi over 6. 6 pi over 6, 7 pi over 6. We went 30 more degrees. 30 more degrees would be 8 pi over 6, but we can reduce it. 9 pi over 6, we reduce it. 10 pi over 6. 11 pi over 6. And then 12 pi over 6 reduces to 2. Now we have our multiples of 45. 45 goes into 184 times. So we know the 45 is going to be pi over 4. That's 1/4 of the way to get all the way here. 1 pi over 4. 45 more is 2 pi over 4. 3 pi over 4. 45 more is 4 pi over 4. 4 over 4 is 1, so 1 pi. 5 pi over 4. 45 more is 6 pi over 4. We reduce it. 7 pi over 4. And then 8 pi over 4. Gets reduced down to 2. Next we're going to talk about the coordinates. This is a unit circle, so the distance to the edge of your circle is 1. So this coordinate, straight across and up and down nothing, it's over 1, up and down 0. Up at pi over 2, you're right and left nothing, but up the radius, so 0, 1. At pi, you're to the left 1 full radius, so -1, up and down nothing. Right and left nothing, but down 1 at 3 pi over 2. And of course we've already done 0 pi or even 2 pi. This is the same coordinate. Right, we're going to look at a 30, 60, 90 triangle. we're going to take this 30, 60, 90 triangle and lay it. It always sits, sometimes hangs, from the x-axis. So notice, if this is a 30, 60, 90 triangle, the small angle here would be your 30. So this is 30 degrees. You would go over the long distance and up a short distance. The long distance we have learned from the past, if it has a radius of 1, which this does, the long side is root 3 over 2. That's your x. Root 3 over 2. The amount that you go up is always the short side of this 30, 60, 90 triangle. So it's a half. That's the best way that I would suggest to memorize these coordinates, is to think about long, then short. If we look at the 60-degree angle, okay, I turn the triangle so it stands on the x-axis. So this is a 60-degree angle. So we're going from 0 all the way up to 60. What are the coordinates? This is just like your XY coordinate that you've done for graphs in the past. What would the grid be? Over here is 1. Way up in this corner would be like 1, 1. But what would our coordinate here be? Well, using our 30, 60, 90 triangle, the short distance is how far you need to go to the right to get right underneath the coordinate. So you're half for the x and root 3 over 2. It's a long way to get to the top. Short, long. You went short to the right and you went long up. You went short for the x and you went long for the y. We'll rotate this so it stands on the x-axis. The 90-degree angle is not touching the y-axis. So we still have a 60-degree angle. X comma y. X is going to be a half, but it's going to be to the left. So on a coordinate plane, we call that negative, a half. The y value is the long side. You got to go up much farther than you do to the left. So we're going to have root 3 over 2. We'll rotate this. Notice how I kept the same coordinate, or the same 60-degree angle hanging on at the origin. The 90 degrees is still touching the x-axis. Short to the left, long all the way down. You drop all the way down. So negative 1/2, negative square root 3 over 2. We're going to keep the same vertex here at the origin. But for me to have the 90-degree angle touching the x-axis and not touching the y-axis, we have to turn it over. So the distance is short to the right and long all the way down. So we have half, then root 3 over 2. Short distance, long distance. You're using your same coordinate rules. X is positive to the right, it's negative to the left. Y is positive up and negative down. We've talked about the 30-degree angle already, how it was long then short. Now I'm going to keep that same vertex of the triangle at the origin. So that'll help you visualize that you're going a long distance and then a short distance to get up here at the 150. Long, short. Long is negative root 3 over 2. The short is up, so it's a positive half. Keep the same vertex at the origin. So it's long and short. Long was negative root 3 over 2. Short is down, so it's also negative a half. Keep the same vertex at the origin. So we would turn that so it hangs from the x-axis. This just helps you visualize that you go long over to get even with that last measurement coordinate, and then down a short distance. Long, short. Long is always root 3 over 2. Short, in this case is down, is negative 1/2. So that got all of our multiples of 30s and 60s taken care of. Long, short, that's the key. There's several other ways that you can look at it. You can look at some patterns of the numbers inside the coordinates, but that's not going to help you in the long run. This way you can visualize in your mind that 30 degrees is long to get over to it and short to go up. 60 degrees is short to go over and long to go up. Short, long. So you know short is always a half. Long is always root 3 over 2. X and Y. X is long, Y is short. Next we'll try a 45, 45, 90 triangle. We stand that right on our x-axis. And you can see from our notes from the other page that the legs of a 45, 45, 90 triangle are always root 2 over 2. So your x value and your y value are the same measurement. So here we get root 2 over 2 and root 2 over 2. Well, as we keep that same vertex at the origin and flip it, we would still go negative root 2 over 2 and positive root 2 over 2 to go up. The 45/45s always have the same coordinate values. So down here, we'll go over negative root 2 over 2, then down root 2 over 2. And then your final one, you'll go to the right root 2 over 2 and down root 2 over 2. To the right was positive x and negative y. I noticed here that actually this coordinate should have had a negative y value with it. Negative for the y's in the fourth quadrant. Negative for both the x and the y in the third quadrant. Negative x's in the second quadrant. And all positives in the first quadrant. So to evaluate, we'll look at a few evaluation questions. So we're going to evaluate what sine of 30 would be. Remember, our coordinates are always cosine, sine. We learned that in the beginning of our lesson. The x values are always cosine. And the reason why, when you look at a right triangle, adjacent over hypotenuse, adjacent is the x-axis. It's a horizontal axis over the hypotenuse. The hypotenuse is a length of 1, so it's adjacent over 1, the x value over 1, which is your x. That's a cosine. From here, sine which is known as opposite over hypotenuse. Opposite is always a vertical side of a triangle when you're working with the unit circle. Opposite is always vertical, so that's always the y. Sine is always y because it's vertical, opposite over hypotenuse. Even when you look at it from a 30-60, from a 30-degree angle, adjacent over hypotenuse. Adjacent is your x-axis, so that's the x's are cosine. Sine is opposite, which shows the side of the triangle that is vertical. So to help you remember that cosine is always the x and sine is always the y, we can think of how SOHCAHTOA works on the unit circle, or it's alphabetical. So we're going to evaluate the sine of 30. Sine is your y value at 30. So let's look up at 30 degrees. The y value is a half. The sine value at 2 pi over 3. Well, you look on your unit circle for 2 pi over 3. Remember 3, that was 60 degrees. So 1 pi over 3, 2 pi over 3 is 60 more. So that can help you remember. 2 pi over 3 is here. You're looking for the sine of it. Sine is your y value. You're over a short way, you're up a long way. So you're root 3 over 2. To evaluate cosine, let's do cosine of 150. Well, 150 degrees, you know in your mind, is way off towards the left. The cosine is your x, so that's the long distance. Long to the side, up short. Long is your root 3 over 2. But remember, it's to the left, so it would be negative. We can also do that with a radian. So 5 pi over 4, well, it's over 4. So you know 4s are the 45s. So 1/4, 2/4, 3/4, 4/4, 5/4. You know you're in the third quadrant. The cosine is your x. You're moving to the left. What were the coordinates again? They were always root 2 over 2. So it's to the left, so it's negative root 2 over 2. Now tangent is a killer. We'll do tangent of 60. Remember we talked about before how tangent was sine over cosine, y over x. So at 60 degrees, we're going to take the y value over the x value. So that means we're going to take the y value times the reciprocal. Those cross out, and you're left with root 3. Tangent of 11 pi over 6. Well, that was over 6. You know that 30 goes into 186 times. So 1, 6, 2, 6, 3, 6, 4, 5, 6, 7, 8, 9, 10, 11. 11 pi over 6 is almost all the way up. So it's long and short. Your x is long, your y is short. So your coordinates are root 3 over 2, comma, negative 1/2. Y over x. Negative 1/2 over x, which is root 3 over 2. Well, to answer that, we multiply by the reciprocal. The 2's can cross out. And we're left with negative 1 over root 3. Well, we can't have a radical left in the denominator. We have to rationalize the denominator, so we end with negative root 3 over 3. So those are some examples of evaluating.